going to veer off just a little bit, talk about an application of two-dimensional arrays. We're not going to actually write a program, I do not believe, on this idea, but I at least want to give you the idea. There are the ideas of graphs, meaning something else other than, you know, a bar graph or something like that. And a graph can be considered something like this. Let me just plot. Okay, you're not going to let me do that? And maybe you've done something like this in a discrete math class or whatever, what I'm just about to show you. Whoops. You could say, okay, there is a connection between A and B. You might even say that it's a one-dimensional thing, a one-way ticket. And then you could say that, you know, there's one that goes that way, and it's two-dimensional, or not two-dimensional, double-ended, you know, you could go either way. This is not the best tool for doing this, right? Forget it. You get the idea. Another one that goes here, and one that goes like that. In fact, let's pretend that all of these are bidirectional. Yeah. So they're not all connected with each other, but there's a lot of connections, right? And you could say that to go from here to here takes 10 whatevers. Maybe these are network destinations, and it takes 10 milliseconds for a packet to go from there to there. Or, you know, these are cities, and it takes 10 hours for your package to be delivered by truck from there to there. That one takes 5. This one takes 6. That one takes 4. That one takes 1. It's real easy to go around the edge, maybe. Not sure if I've left any off. Well, that looks like a 7 to me. And that's a 2. So this is a graph. It's called a weighted graph. I'm not sure that I've put a line, you know, on directly a weight for every single line, but I think I have. You can represent this as a two-dimensional array. How many elements, how many rows, and how many columns is it going to have? Well, A, B, C, D, E. Notepad is definitely not going to be the right tool to do this in. So why am I doing it with Notepad? So anyways, we're going to need something that comes up with names, hooks up names and numbers. So 0, 1, 2, 3, 4, 5. There is no F. Apparently we only have 5 points in it. Yeah, that's why it looks like a pentagon, right? Okay, so then you could set up an array. It's going to be a 5 by 5 array. And thematically, I'm going to go ahead and use the letters rather than the numbers. But thematically, it would look like this. Is there a connection between A and B? Well, is there a connection between A and A? I'm going to say no. I don't see a little loop there. I might change my mind and say that, yeah, it's connected. But anyways, there's no connection there. Is there one from A to B? Yeah, there sure is. And it has a cost of 10. It takes 10 whatevers to go through it. Is there between one A and C? There is. It's got 7. Is there one between A and D? Yeah, there is. It's 2. And then is there one between A and E? Well, there's not that time, so we're going to say 0. How about B? Well, if there was one between A and B, there's one between B and A. B and B, no. Is there one between B and C? You tell me.
No.
Nah, there's not, so we're going to put a 0. How about B and D? Do we have a line between B and D? Forget the fact that there are arrows and stuff like that. Let's just assume that they're bidirectional.
Yes.
So yeah, there is. And B and E, yes, with a weight of 6. All right, C to A, yeah, it's a 7. C to B, nope. C to C, nope. C to D, yes, a 1. And then C to E, yes, 1. You're going to kind of see that this is kind of like a mirror image, right? 0, 10, 7, 2, 0, 0, 10, 7, 2, 0. D to B is the same as D to B, so that would be a 5. D to C, did we have a C to D? Yes, we did. It was a 1. A D to D is a 0. And a D to an E is the same as an E to a D, which we hadn't figured out yet, so that's a E to a D. Yes, it's a 4. So if these were spaced out a little bit easier to see, like that, you'd see that we kind of have this row of a diagonal row of zeros upon which this stuff is reflected. But if it had not bidirectional lines but unidirectional lines, you know, sometimes you'd have one going from B to D, but you wouldn't have one going from D to B. So it would not always be symmetrical like that. All right, the last set. E to A, no. E to B is a what? 6. E to C is a what?
1.
A 1. E to D is a 4. And E to E is a 0. That's called a graph. You could store that in memory. And one of the common programming problems is find a way through this graph that visits every point for the lowest cost possible. And there's an algorithm which says you just always pick the least expensive path until you've hit them all. So we're going to do that. All right. What's the least expensive path? 2, 7, 10. Okay, we're going to go to 2. So we have hit both points A and D. We could mark them off on our little thing. We have visited A and D. Now we're here. What's the next?
1.
Yeah, we're not going to go back that way, so we're going to take that 1, and we're going to get to C. So now we've hit all of these so far. Now we're sitting at C, but we don't want to go to D and we don't want to go to A because we've already hit those, right?
Yeah.
So where are we going to go next?
E.
We're going to go to E. And I should have been writing the order in which we traverse these. Let's go ahead and do that. We started at A, we went to D, we went to C, we went to E, and then really there's only one choice left, which is E to B, 6. Whoops, what am I doing there? There, all right, so now we've hit them all. And maybe you could see that that could be done pretty easily algorithmically. I'm not going to go, into it, but you'd be searching a table. I'm sitting at point 1. Which one of these is the least expensive? 2. Great. So now I'm going to go down to the D row. I'm sitting on D, and where am I going to go next? Look for the least expensive one that you haven't already visited. So 1. So that would take you to C. So now you're sitting in C, and you're going to look for the least one that you haven't already visited. Well, we've already hit D. We'd be marking them off in a list. So we're going to go to E. And now we're sitting on row E, and we're going to go to the least expensive one that we haven't already visited, and there's only been one that we haven't visited yet, which is B. So we have mapped our way through this graph using the least expensive route. And it gets much more complicated if these are, you know, not bidirectional paths. Just want to kind of have that tucked away in your brain. Writing code for that or giving y'all code to figure that out is not, you know, appropriate for this class. But I hope it just kind of lodges in your brain that these things can contain more than just rainfall tables, you know. And when you have a whole bunch of routers on the internet, for example, it has to decide, or these routers have to decide, what's the fastest path to get your packets from, you know, New York to Seattle. There's not a direct wire between New York and Seattle. It has to get onto this pathway, and then it has to be transported over this backbone to this server, and then from there it can get there. And so it has to kind of predict which is going to be the least expensive way of getting there, least expensive being in terms of time usually. So these things have tables of other routers that they can communicate with. And if one of those routers ever stops responding to data, it knocks that one off its table, you know, temporarily, so that it won't keep trying to send data to that router. And it needs to go to another one. So that's why, you know, you could take out a router somewhere on the internet, and hopefully it would still be able to respond. You know, it would just start, that router would send data to a different router. You know, maybe it's not the fastest way to get that data. Maybe you have to send your data from, you know, from New York to Seattle by, you know, going up to Montreal rather than sending it to Dallas, but it can do that. Tables are an extraordinarily important topic that we haven't really we don't adequately cover it in our curriculum. If you go and you take a 4-year college course in computer science or stuff like that, you will learn about routing algorithms and packets and how the times between the destinations, the packet times, are used to make decisions about which routers are still active and things like that. I'm pretty sure we do have a router configuration class of some kind still. Do we do that? Do we have a Cisco routing class?
I took system security.
Okay.
And then
Covered some stuff like that. That's cool. That's cool. I'm glad we do that. I don't think I'm going to talk too much about more about two-dimensional arrays. We're going to save the rest of that for Java 2, which I hope you all will take. Oh, I forgot to post this, but I'm going to offer any of y'all who enroll in a computer science class here, you know, a CIT class here, an extra 3% on your final exam. So what I'm going to need to do is set up a Dropbox to where you could write up a note that says, hey, I enrolled in such and such. I'm enrolled in, you know, CIT1613 or, you know, in the scripting or whatever. And that way you get 3 extra points on your final exam. And the reason that the professors are encouraged to do that is just because the earlier people enroll, the more likely it is that the class will actually make. You know, it kind of stinks when you get down to it and they have to make a decision. You know, well, it looks like there's only 4 people enrolled in this class. We can't offer it this semester, and so they cancel it. But really, you know, there were more people waiting to take it, but it gets canceled, you know, because. So let's make a note to that effect. Well, I'll just make a note to myself here. You know, extra 3 points, final exam credit if you upload a note saying which CIT classes you are enrolled in. I'll make a Dropbox for that. That makes sense, y'all? Yeah. Might bump you up from a B to an A on the final. Yeah. If you're going to take the courses, you may as well, you know, get a little bit of extra credit for it. I keep popping that open, and that's not what I want. I want this. Arrays of objects. So far, what we have been dealing with is arrays of floats, right? Or strings or ints. That's really all we have done. And a string is an object, so that kind of crosses the line between what we're going to do here now. But what we're going to do is we're going to come up with a class, and then we're going to make an array of objects of that type of class. So for example, we could have a car lot that's got cars on the lot, and we're going to make an array of all the different cars, and I did not mean to launch Visual Studio, that our car lot currently holds. So we're going to need to come up with a car class. And we're going to make it simple. All a car has is a name and a mileage, or a name and a color and a mileage. How about that? Or a name and a mileage, excuse me, a name and a color and a sales price. That's really all we care about, huh? How much can we sell that thing for? So let's create a new project, but then let's insert a new class. I'm going to remove my package statement. I'm going to move this one over into the correct place, move class to correct folder. So over here in my projects, in the same package that my current.java file is in. It's in my default package since I moved it there. I'm going to make a new one called car. So what I did is I right-clicked on my default package, or whatever directory is holding your current.java file. You can see it there. Yeah, Java class. Thanks. And right-click, insert new class, call it car. I'm going to make a car. It's going to have a couple of members. Public string brand or model. Public string color. And public double price. Now we're going to go back and we're going to use that class over here. We're going to make some cars and we're going to add them to an array. So final int num underscore cars is equal to 3. We're going to put 3 cars into our array just so that it doesn't take forever to type this stuff in. Now let's make our array of cars. Car, but we want it to be an array of cars. Inventory is equal to new car, and that's how many of them we want. And really I'm supposed to put the square brackets after it, am I not? Java's loosey-goosey. It allows you to do either thing. I like putting it How were we doing that earlier in the semester? Well, how do we do it here? I mean, we've done a million of them, and now my brain has flipped between C++ and C# and Java, and I don't remember where to put the square braces because either one works. What have they suggested here? Putting it after the type. Okay, we'll do that. So car, square braces, inventory is equal to new car. Now all that does is it allocates a space for 5 references to a car, but not 5 car objects themselves. We haven't made any car objects, right? We've never used the new operator to make any individual cars. All we did is declare an array. So if we made a loop that printed out our cars, we're going to be kind of disappointed. There's nothing there. But let's go ahead and do that. But let's make a method that's going to print our inventory, rather than just keep adding for loops over and over into our code. So public static void print inv for inventory. And what does it need? It needs an array of cars. That's what our inventory is. So car, square brackets, inventory. Maybe I should have just called it, CA for car array or whatever. Make it easier for us to type. All right, let's just use a for each loop to print out our cars. For car C in our inventory, system.out.println the cars model. That'll be enough. It's going to be enough to prove that it doesn't work. It's going to blow up on us. But I'm doing this to prove a point. So now we have an inventory of cars. Let's call print inv and pass in our inventory. What we're going to see is that it won't work. It's going to complain about a null pointer exception. What is going on there? Well, instead of printing out c.model, let's just print out C all by itself, because you can do that. If you declare a reference to something, you can just print it out, and it's going to print out some kind of memory address thing. But let's do that. Let's take that out and see what is actually stored in our array. Not by the instance members, but by the element itself. And it's got 5 nulls there. So the array is, we have an array. It's got room for 5 car objects, but right now the references aren't filled in with any memory. Well, let's add one to our array. Car C1 is equal to new car. C1 dot color is equal to red. C1 dot model equal to Jeep. C1 dot price is equal to 10,000. And let's add that to our array. So we're going to put this into the first element of the array. What's the index value for the first element in an array? Invariably, the first element in anything in a programming language is index 0. Yep, so inventory 0 is equal to that car. Now we have stored that reference to that car object in the inventory. Now let's print our inventory again. Or let's just move that. You've seen it, right? You've seen those 5 nulls come. We don't need to keep printing out those 5 nulls. So just cut that print inventory statement and paste it below the creation and addition of our car. And there we go. We see. Okay, I've done something really dumb. I said final int number of cars 3, and then I said new car 5. That was kind of dumb. Why don't I just delete that line? Get rid of that final int. Or I could have put it there, but whatever. So when I run it now, what do we see? We see that there are still 4 nulls in our array, but the first one actually has a memory address, or actually more appropriately a hash of the address where that car object is stored. Now I'm almost making this too complicated when I say that, but I'm trying to get the idea into you is that now that we have an array of objects, we don't just have primitive numbers in here. Right now everything in that array, until we start adding things into it, it's just got a 0 in it. And there's no such thing as a car. We haven't created any car objects. Well, now we've created one. But is that useful? Is it useful to see that memory address? Not really. Let's go back to where we were and see if we can actually get that printing of the model out. So how about system.out.println, this is inside of our for loop, c.model. Get rid of those curly braces. parentheses. Here we go. It'll work for the first one. Because the first one isn't null. So we did print that we have a Jeep, but then the next one is null. How could you fix that? We could say if object not equal to null. Let's do that. I'm going to get rid of that print line because we know that it's printing null if it is a null entry in the array. And so I'm just going to do this. If C is not equal to null, if that array element is not pointing to null memory, then go ahead and print the model out. To be more awesome, let's go ahead and print out the color. So C dot color plus a space plus C dot model plus a space. We should have used printf. Let's be professional programmers. System.out.print line. We're going to say that no color is more than 10 characters long, 15 characters long. So 10% 15s. We're going to say that no model is more than 15 spaces, percent 15s, and we're going to say that the price is going to have 2 decimal places, and then backslash in. That should actually say printf. So system.out.printf, percent 15s, percent 15s, percent.2f, and then let's actually fill in that data. C dot color, comma, C dot model, and then C dot price. Close parentheses in semicolon. And you don't have to space it out like I have. You could put all yours on one line, right? There you go. So now we'll actually print the car out. Why are we having to do all this rigmarole? Because again, we have a partially filled array. So we can't just run through the rest of the array, because when you create an array of objects, of classes, then until you actually put items in there, then they are null references, which means just, it hasn't been allocated yet, and so it's got a 0 written there where the address of it should be. Alrighty, I made a mistake. What did I do wrong?
The spaces are too big.
Pardon me?
I'm not sure what you did, but it ran for me, but the spaces are really big.
Oh, let's run it again. What are you complaining about? Illegal start of expression. Somewhere I have a plus. Okay, yeah, right there. I'm going to put my little comments. That's the end of an if statement. That's an end of a for. And this is the end of the print inventory method. Okay, so. And there we go. We have our red sheet. Let's add another item to it. Car C2 is equal to new car. Did we talk about constructors and custom constructors? Do I see heads nodding yes? We did talk about constructors?
Yeah, I think so.
Because it sure would be nice if I could do this. I have a blue, comma, Corvette, comma, that I'm selling for $15,000. Did we make code that supported that syntax? Yep. Okay, we're going to do that. Let's go add a constructor that allows us to do that, just to make it easy for us to, create some more test data. We're going to go back to our car class, and if you recall, what is a constructor? A constructor is a method that has the same name as the class. So public car. A default constructor is one that doesn't accept any parameters, like that. Why do you add a default constructor? Java gives you one. You don't have to add that until you add the custom constructor, the parameterized constructor. Once you add a parameterized constructor, it no longer gives you the default constructor. I'm going to prove that to you by not doing that. Let's do string color, string model, comma, double price. And usually I put this underneath the variables. I'm going to move my instance variables up above my constructor. Sorry about that. And so then we say this dot color is equal to color. This dot price is equal to price. And this dot model is equal to model. I kind of did them in the wrong order, but it doesn't matter. So we have a constructor so that we could create cars like this. That is no longer a syntax error. Unfortunately, that one is. And the reason why is what you provide support for parameters in your constructor. The default constructor that doesn't take any parameters, Java stops giving it to you for free. We have to go and add it. So we're going to put in a default constructor. Public car. There, that's enough. Now run it. Red Jeep. I forgot to add my Corvette to the array. So I'm going to go back and do that now that I have my constructor ready. So everybody got this page of code done. Not going to mess you up when I tab back to main.
No.
Okay. So here I created a second car. Let's make this the second element in the array. So inventory 1 is equal to our second car. We could have even reused the same reference here. We could have just done this. C1 is equal to new car, and then inventory element is equal to C1. Why? Because this isn't the object itself, it just holds the address. It's just like a piece of paper with your home address on it. Just because you lose a piece of paper doesn't mean that your home is gone. Right? And then you can erase that address that's on your piece of paper and you can put a new address on it. Address, you know, the address of a friend of yours. So we are reusing a reference, trying to break up the idea that that variable is the object. Those terms get used interchangeably a lot, but that's kind of sloppy. C1 is not an object, it's a reference to an object. And then here, C1 is not this object, it's a reference to that object. But once we store it there, now when we run it, we're going to see that we have two pieces in our inventory. Let's move that print statement down underneath our second car. Print inventory goes there. Then we run it. And there we go. Now we have two things. Take your code and go ahead and add 3 more cars to it. I would recommend that you use this syntax, right? Because that's a lot faster than doing it like that, you know. So I'm not going to type it up here, or maybe I will at the end, but I want y'all to go ahead and create 3 more cars and add them to your inventory. One little thing that I'm noticing is that I'm hard coding these positions, 0, 1, 2, and 3. I probably ought to be using a counter that I would increment between those. But I already went with this style. So for some reason Camrys are incredibly cheap on my lot. So maybe you see what I mean. I have 0, 1, 2, 3, and 4. I could replace that with a variable and just increment that variable each time. I'm going to go ahead and make that change, but I don't care if you do. Watch this. Int counter or int index is equal to 0. And then I'm going to use that word index inside each one of these.
Is it possible to store the concept of index plus plus into a single variable? No.
I can't think of a way to do it in this language, no.
So you're going to be like index plus plus equals C, and then just put C inside.
Now, what we want to be able to do, and we're going to get to the point of it, is where we can make a list, where we could just say list append car1, list.append car2, like that. That's nice. Unfortunately, arrays don't really support that. And that's why we're going to learn about something else called an array list. All right. Where did I print my inventory at? I probably deleted my call to print inventory. I guess I do have two calls to print inventory because I see my inventory twice. Oh, yeah, what do you know? To resume. I think we saw the nulls previously. Did we not do something like this? String colors is equal to new string, and then print that array out and see a bunch of nulls. I'm sure that we've had that happen. For every string S that's in the colors array, system.out.println that color, that string, and we're just going to see all those nulls again. Wish I had a stylus drawing tablet thing going on up here, because if I get up and draw on the board, then the people who are watching the video don't get to see it. But that's too bad this isn't an online course, so we're going to go ahead and do that. Guess you get to listen in. Is the projector so bright that you can't see what I write on the screen? Is that a true statement? Do I?
There's only one spot that says that it's good.
All right. So what is happening when we do that new statement? Okay, so when we make an array of strings, we say, yo, I want my array, string array, is equal to new, and we say we want 5s. I know that's not the correct syntax, but you get the idea. Now out in what's known as the stack, it's one part of memory. It goes ahead and creates a data structure with 5 slots in it. And the slots can hold addresses of objects. But we haven't created any objects yet. We've just created a box that can hold, just like you buy a carton of eggs. Well, you could buy a carton that doesn't have any eggs. You know, if the chickens haven't laid the eggs in it, you have an empty carton. So then when you come and you do, okay, you know, string array, element 0 is equal to red. What happens? You have a different area of memory called a heap. And out there gets added this string. And I'm going to put some numbers out here and pretend that they're valid. We're going to say like at memory address 10 is the color red. And we said that element 0 gets that. So it writes out a 0, 0, 1, 0 there. And then later on in our program we go, okay, I want the color black. Because SA subscript 2 is going to be equal to black. So it goes and adds that to the next place in memory. Let's just say that's 0, 0, 2, 0. All right, that's item 0, 1, and 2. So we got 0, 0, 2, 0 there. And so on until we fill up the array. You know, if we printed it out now, we'd see red, null, black, null, null. So there's a distinguish between the idea of the object itself, which is out here, and then the address of it, which is what gets stored in the array. I could do the same thing with the cars, right? We have an array of 3 cars. When we allocate the array, it doesn't have anything. But then you do car C1 is equal to new, you know, blue Ford. This is out on our stack. This is out on our heap. I may talk a little bit more about stacks and heaps in a little bit, if I'm so inspired. But anyway, so we created a new car there. And so we have a car object with the information that it's a blue Ford. And this might be at memory address 2100. So we write that out because we said that our inventory element 0 is equal to C1. And so that copies that address into there. And now let's say that we do the same thing again. We reuse that reference and we make it a red Chevy. And you can read my writing. So it adds a second object out here, maybe at memory address 2200. We have another car object, which is a red Chevy. And then we can say that inventory element 1 is equal to C1. Well, what did C1 actually contain? That memory address. So we write it into there, like that. And all of this stuff is contiguous. If this was all in the same program, all of this is contiguous in memory. Each time we allocate something new, it just gets added on. And then when that memory is no longer needed, it gets cleaned up by the garbage collector. Now what does that really mean? Say I have some code that looks like this. If customer wants car is equal to 1 because they want it, or true, then we're going to create a car. You know, C is equal to new car, and it's a yellow taxi. And then we do something with it, whatever. I'm going to say we don't add it to an array though. We create a new car, maybe we print it out so that they can go and they can take it to their salesman or whatever, and then they're done. So what happens here? We created a reference to a car object, so out on our stack, once we get in the curly braces, we have a variable of type car, and then out on our heap, we actually have that car created. So out here we have a car object, which has got, you know, yellow taxi in it. And let's say that's at memory address 300. These numbers don't important. Okay. Now when it leaves this curly brace, could we get to that C variable anymore? Just like if we had int x is equal to 12. Once you leave those curly braces, can you print 12 out? The answer is no. Once it falls out of scope, that's no longer available. It's called dereferencing. No, that's not the right term for it. But it falls out of scope. The same happens for C. Since C was declared inside here, once you get to the curly brace, this variable disappears. There's nothing left on the stack anymore, except, I mean, that one would have disappeared too. We would have had a car C on our stack, and we would have had, you know, an int X out on our stack, but they're gone. Unfortunately, we still have this car out in a heap, wasting memory. This is called an orphaned object. Nothing is pointing towards it anymore. So what has to happen is that something has to go and release that memory. And that's what the garbage collector in Java does, is it goes and it notices, oh, by the way, nobody is pointing to this car anymore. I don't need it anymore. And so it goes ahead and erases that memory so that something else can use it. Now without garbage collection, you have to manage your memory by hand. Every time you allocate something, then you better deallocate it. And if you don't, that's called a memory leak. And Firefox as a browser was notorious for having memory leaks. So that the longer it ran, the more and more RAM, the longer you left it running, it kept allocating more and more RAM for the web pages that it displayed, and it never released it. And so you could see that if this was a for loop and it created 10,000 new cars, but nothing ever cleaned up those cars, that'd be a real problem. You would have 10,000 cars out on a heap that weren't cleaned up. But garbage collection handles that. Makes it easier to program. In C++, that doesn't have garbage collection, then you have to, you do have to keep track of that. So here's their example. They created a sales clerk object. They allocate an array of sales clerks. They made it for long. Right now they've only created 3 objects. They haven't assigned anything into the last element of the array, so that one's got null in it. Here they're using a counter, filled elements, to handle the idea of partially filled arrays. What did we do? We checked to see if that element was equal to null, and if it equaled null, then we didn't do anything with it. Instead, they're using filled elements. They're using a counter. Just like we talked about with partial arrays, you only have 10 pieces of good data in a 100-element array. Then you loop and you go from 0 out to 9, and then you stop there. That's a totally valid way of doing it. I kind of like checking for null because that lets you insert data into the array out of order, if you ever have the need to do that. Okay, so beware, to create an array of objects, you must instantiate the array with a new operator, but you also have to instantiate each object. We created the array, but then we created 5 cars. The for loop is a for each loop is the alternative to the traditional for loop. It's handy when you want to iterate through all the elements of an array. For data type colon array. So for string s colon colors, for car value or whatever we call it, colon inventory, that kind of stuff. But when you read it, you just say for each element in element. And I wish they had actually used that syntax. That's the syntax that it is in the C# programming language from which Java borrowed this concept. You use for each. But that's what you say when you're looking at it. And so sometimes when I'm reading this to you as I type it in, I will say for each, but it's not. It's for, data type, variable name, colon, array name. So let's do one more example of an array of elements. Let's make another class. Rectangles. Seem to love those geometric shapes. So go back to your code and we're going to create a rectangle class that has a, a height and a width member variable. So I'm going to come out here to my source packages, and in the same package as my car and my other Java file, new Java class rect, short for rectangle. I'm going to pretend that everything is on even integers, so public int height, public int width. We may as well give ourselves a constructor so that we can construct these things easily. So public rect parentheses int height comma int width in parentheses curly brace. Now I want to set the height and the width instance variables. So what syntax have I been doing to do that? I just did it with the cars. I'll flip back to it. There we go. Yeah, we're going to use the this reference. This dot height is equal to the height parameter. This dot width is equal to the width parameter. Now, what do we do when we have a rectangle class? We provide a calculate area. But let's also give ourselves a toString method. Why are we going to do toString? So that we could print it out. We can print out the rectangle pretty easily. So public string toString we need to build a string and we need to return it. We're going to use string.format, which follows the same formatting rules, the same syntax as the printf statement. So string s or string r for return. S is equal to string.format, and this looks just like our printf, this stuff in here. We use placeholders. So we're going to say rectangle height equals %d, because d is for integers, width equals %d. And we can make that look prettier if we like put the height and the width inside parentheses or something. Don't let that make it too hard for you to type. And then now we need to pass in things for those placeholders, right? So after the ending quote, comma, this dot height, comma, this dot width, closing parentheses, semicolon. And then let's return that string. That way, if we say print my rectangle object, it'll go ahead and print out something nice rather than just printing out a memory address. And let's do a calculate area, a get area method. Public int get area. And what is the area? It's equal to the height times the width. Return this dot height times this dot width. All right, we have a rectangle class and we have a constructor. We have a way to print it out or to convert it to a string. And we have a get area method. Let's go use it. Going back to our .java file, to our main method, let's put it up at the top. Let's declare an array of rectangles. So what's the syntax? Rect, and then what do we do to indicate that it's an array? Yeah, we use our square braces. We need an array name. Shapes is equal to new rectangle, and how many rectangles do we want? Let's say 4. You notice that this is a problem with arrays. If we're not really sure how many rectangles we need, we have to pick a number that's large enough for our expected size. that kind of be a problem with a car lot, right? What if it's a huge car lot, Hudeberg or whatever, and it's got thousands of cars on it, as opposed to, a little used car dealership who's only got room for 100 cars. You have to allocate enough, for the largest worst case scenario. But anyways, okay, so let's create some rectangles. Shapes at position 0 is equal to new rectangle, and this one's going to be a 10 by 20 rectangle. Shapes, shape array at index 1 is equal to a new rectangle, and just make, 4 total. Numbers don't matter. You can pick your numbers. These are anonymous objects. They don't have names. We don't store them in a variable first. We just slam their references directly into the array. There's nothing wrong with that. Why store something in a C1 variable and then just copy C1 into an array if you can do that directly? Now let's print those guys out. For parentheses rect R colon shapes, for every rectangle R in the shapes, let's print it out. System.out.println R. Now when we run it, hopefully we'll see 4 rectangles. I'm getting a lot of nulls here. Oh, that's for my colors array at the very bottom. But here we go. That was our list. That was our shapes array containing all those rectangles. And we got this nicely formatted output. How did we get that? That's the responsibility of the toString method. Come back over here and change toString to something wrong. Like put some underscores in front of it. And then run it again. What you're going to see is that since it's named the wrong thing, it's just printing that stuff out. The name of the class and then a hash value for the memory address. It's not useful information. So that's what toString is good for. I am going to go and get rid of those 5 nulls at the bottom. They're bothering me, so I'm going to scroll down to the bottom of my main method. And where I had that, I'm just going to comment the whole shebang out. If you had it. If you don't, that's fine. All right. Now we didn't call the get area. If we wanted to get the area of a specific one, we could. Like, int area is equal to shapes subscript 2 or square brace 2 and square brace dot get area. And we could print it out. Sure. That would work. Then we could do the same thing for 0, 1, and 3. What if we wanted to add up all the areas? We could do it kind of slow like that. Store each one into a different variable. Add them all up. But we could write a loop to do it, right? Let's do that. So we're going to declare a total area variable. Total underscore area is equal to 0. And then we're going to add each area that we find to it. Another for loop. You'll find that you use loops an awful lot when you're working with an array, with arrays. So for every rectangle R in the shapes array, total underscore area plus equals R dot get area. And we could print it out. System.out.println total area equals. Well, maybe we should have been printing the areas we went along. Let's do that. Let's print the areas out as well. Yeah, where are we going to do that? Let's do it up here. When in our loop that prints the arrays out, prints the rectangles out. Let's change this just a little bit. So I went up here and I'm going to print out the rectangle itself plus a space plus area equals plus r dot get area. I hope that didn't make it look more complicated. I'm going to rewrite that. Bugging me. System.out.printf %s space area equals %d \n end quote comma r dot get area parentheses in parentheses and then one more in parentheses. And then down here, after we've calculated our total area is equal to, end quote plus total underscore area, into parentheses, semicolon. Try to get all that on one page. Alrighty, there we go. I'm going to rewrite that for loop, or I'm going to write it again to use indexing rather than for each, because I want y'all to have that ability in your brain, not to rely on for each. Maybe you'll hit a language in which for each isn't supported. Well, I'll skip talking about that for a minute. So let's go and do that. I'm going to go back here, and you see this loop right here that calculated the area using for each? We're going to do the same thing with index-based access rather than for each. So I'm going to reset my area to 0. Total area is equal to 0. And then for int index, or I, is equal to 0. Index is less than the length of the array. So shapes.length, semicolon, index plus plus. If I just used I, it would have all fit. So I'm going to change those indexes to I's. And then total underscore area is equal to, now how do I get that specific, how do I reference that specific element in the shapes array? First I want element 0, 1, 2, 3, 4, 5, but fortunately I have an index counter. So what am I going to type here? Here it was easy. I had this, I was using for each, so I could just use that variable. But I can't here. I have to do shapes subscript I, or whatever you called your index counter, but not semicolon, dot get area. And let's print them out the same way. I want you to be able to do both, and I know that what happens is when I give an exam, people get them kind of cross-wired. And I'm sorry about that, but you really need to be exposed to the idea that you can do it either way. You can do it either with the index, which is what we did here, or you can do it with a for each loop. So let's print them out. As a matter of fact, that's what I want you to do by yourself right now. If you get stuck, that's okay. Of course, I'm going to come and help, but use a for index, not a for each, loop to print the rectangles, the shapes array. So I'm just going to tack on my loop that prints above my first for loop that printed. I know y'all put yours further down. But for int I is equal to 0, I is less than what? It needs to be less than the length of the shape array. So shapes.length, semicolon, I++, and then system.out.println shapes subscript I. Plus a space, plus shape subscript I dot get area. I should use printf and make it look nicer, but all right, other than the fact that this doesn't have the word area in it, they are working the same. All right, I think that's enough for today. So I know some people have typos that they need to work through. We'll go ahead and end a few minutes early so that we can do that. Let's see if,
Scroll up just a little bit, please.
scroll up.
Yeah, right there.
Okay, cool. And the Dropbox is there for y'all to submit it.
Are there supposed to be two public static void main arguments?
We had a public static void main print inventory, and we had a public static void main. No, only one main. You can only have one main per Java class. I'll come look.